Good evening, squad. Today I want to teach you how to write an equation and a verbal description for a relationship from a graph. So you know the drill. Make this the title of the next free page in your math notebook. Then mark that page, close it up, turn on that brain, and let's go. So a while back, quite a while back, you guys took a quiz and did an assignment, or we worked on things all. It looked kind of like this, where maybe I gave you a graph and you had to do all of the other representations of this relationship. You had to make the ordered pairs, then the verbal description, then the equation. And graph to ordered pairs was not too bad. Verbal description, writing a verbal description was really tough, and writing an equation was really tough. It wasn't so bad if I gave you the verbal description to take that, make the ordered pairs, make the graph, but it was hard to write a verbal description, say, from that, or an equation from that. Those were really tough, and I still wanted to show it to you, but I think now we're ready to make a lot better work out of that today, thanks to understanding slope-intercept form. Because back when we did those, had no idea about slope-intercept form, but now when you see an equation like this in slope-intercept form, you know a lot more about it than you knew back then. You know that this is going to be the slope, which is the same as the unit rate in whatever's going on here. And you know that this is going to be the y-intercept, which is the same as the initial value in whatever is going on here. And now that you know that, going back and writing verbal descriptions and writing equations is going to be a lot more manageable. So let me show you how. So here is a graph. In the past, the first thing we would have done from the graph is write ordered pairs. But thanks to slope-intercept form, a lot of times we've been able to skip that step. Nothing wrong with it. I'm not telling you don't do that or you can't do it or you'll get the wrong answer if you do it. But we've been able to kind of cut corners and go straight to the equation because we know about that slope-intercept form. That has been nice. So that's the first thing. This was really tough when we had ordered pairs to say, okay, what's happening to y? I multiply it by 4, then I add 5. And that was just hard to do. But slope-intercept form makes it actually not that hard to do. Because now I know my equation y equals, if I find the slope, looks like they've given me 2 ordered pairs to use to do that. So let me find the slope. X changes by 1, 2, 3, 4, 5. Y changes downward. That's going to be negative 1, 2, 3, 4. And slope is a y to x ratio. So the y was negative 4. The x was by 5. So I know my slope is negative 4/5 times x. Remember, if I just find my slope, it becomes the coefficient of x when I know it. That would have been so hard to do this way. Figure out that I have to multiply this by 4/5, then do something else. But here is super easy. And then I also add or subtract my y-intercept. Y-intercept is there at 3, 0, 3. So y-intercept 3, add 3. Boom, I've got the equation like just that easy from the line. All I have to do, find the slope, find the y-intercept, make my equation. So that's just so much easier than it would have been the old way. So I want you to just skip all that and go straight to the equation if you can. Verbal description. We've also learned how to talk about what the slope and the y-intercept mean. So I would simply write it out that way. We usually say the equation or the relationship starts at or has an initial value of. So I'll probably use that initial value language, has initial value of 3. And then we talk about the slope. I'm going to talk about the slope using that each time x increases by 1, y decreases by negative 4/5 method. So, and then each time x increases by 1, y decreases by the slope by 4/5. I'm going to say 4/5 rather than negative 4/5 because I said decrease. decrease kind of covers my negative part of that. And that's it. I can just look at the graph. I know how to write in slope-intercept form. And then if I know how to write in slope-intercept form, I just talk about the y-intercept and the slope. So it's a lot easier to transfer between representations now that you know about slope-intercept form. Also, you know, sometimes they're not always abstract. This is a real thing where I guess the temperature of some sort of tank of water is decreasing. Same thing, I'm going to skip all this. And I'm just going to cut straight to my equation and then use that to talk about my verbal description. That's the easiest way for me. So when I look here, I'm going to do slope-intercept form. So y equals, start with the slope. They've got a lot of these marked for me on the slope. I'll just pick, say, this one. So it looks like if I go 2 squares, x increases from 1 to 2. So that's just an increase of 1. Going to have a negative slope again, sloping downward. Y decreases from 80 to 78. That's minus 2. And that gives me a y to x ratio of negative 2 to 1, which is negative 2 is my slope. So y equals negative 2x plus 82. And the only difference now, my verbal description, last time I wasn't talking about anything. So I just said starts at and changes by. Now I am talking about something. This isn't an abstract relationship. This is a real relationship. So I can actually talk about what's changing. I can say the temperature starts at 82. And then my slope is an actual real thing now. So rather than saying each time x increases by 1, y decreases by, I can actually just talk about the temperature. So I can say the temperature starts at 82, and this is a unit rate, drops by 2 degrees each hour, rather. So I can just say that. The temperature starts at 82 and decreases 2 degrees. Notice slope each hour. And that's it. So now writing these is so much easier than it was back before we knew about slope-intercept form. So open that notebook. Let's do 2 together. We'll do an abstract one and a not abstract one, concrete one. We'll start with the abstract one. So what I really want you to do, go ahead and kind of sketch out your graph. I like to make all 4 of these because I like to remind you that they're all different ways to represent the same thing, though we don't deal with all of them. And really today, my goal is for you to be able to skip this step when it's not asked for. I want you to be able to cut straight to an equation from the graph. So I'm going to write that in the slope-intercept form. So y equals, let's find the slope first. I'll use these 2 points that are marked for me. X increases by 3, y decreases by 2, so negative slope, you can see it sloping down. So the y to x ratio, negative 2, positive 3, so negative 2/3 is the slope. And the y-intercept is here at 5. Look how fast that is. I mean, remember what a pain that was? It would have been an even bigger pain if there was a fraction here. You guys would have panicked all the time because that's what you do with fractions. Would have been a whole thing. But now we got the equation done just that fast. And all we have to do is talk about the initial value and the rate of change here as we go. So we would normally just say, with an abstract one, would say has an initial value of 5 y-intercept, and each time x, oops, sorry about that, like down at the bottom, it's making my increases by 1. We got my slope. I'm talking about, you could also do this too. Each time x increases by 3, y decreases by 2. That's actually fine as well. I usually just use the unit rate slope talk, negative 2/3, because I see it here. I'm really going kind of from here. Y decreases by 2/3. And you notice I don't have to say negative 2/3 because I said decreases. That kind of covers my negative. So again, you could also say each time x increases by 3, y decreases by 2. That would also be fine, either one. I just kind of use the slope that I see in the equation. All right, let's do a concrete one together. This is not abstract. The opposite of abstract is concrete or realistic, something like that. Here we go. We've got temperatures again, hours again, and we're going to skip this. We're not going to use the ordered pairs to write the equation anymore because that's a pain. We're just going to cut straight to the equation. So we're going to do it in slope intercept form. Good to write for your notes. Y equals, let's see, let's start with the slope. Looks like each time x increases by 2, notice that's 2, not 1. The temperature increases by 4. So the y to x ratio for that would be 4 to 2, which is 2. So that's a slope of 2 and an initial value of 8, y-intercept of 8. So the only difference now is in my verbal description, I'm not just going to talk about x and y, I'm actually going to talk about temperatures and time. I'm going to say each hour, each 1 hour. Oh, no, I'm not. I'm sorry about that. I got to start at my initial value. The temperature starts at 8 or has an initial value of 8 would be fine too. And it increases unit rate to each hour. Increases by 2 degrees each hour. And again, if you wanted, instead of using the slope here, to use this, you could also say it increases 4 degrees every 2 hours. That's the same thing, totally fine. Y'all, that is how you write an equation and a verbal description from a linear graph. Hope that made tons of sense. If not, go back, give this another watch, and I can't wait to see you tomorrow.